Hi guys, welcome back to our flipped videos. I don't know if you missed them, but I sure have. We're going to take a look today at growing sequences, and so we've talked about arithmetic sequences in the end at the end of Unit 2, Part 3. So we're going to revisit arithmetic sequences for just a little bit, and then we're going to take a look at a different kind of sequence that's not arithmetic, and that's pretty much what this unit is going to focus on. So let's go ahead and get started. So we're going to start by reviewing arithmetic sequences. And if you remember, no, maybe you do, maybe you don't, from the end of Unit 2, Part 3, an arithmetic sequence gets from one term to the next by adding the same value. So arithmetic means to add the same value to get from one term to the next. So an arithmetic sequence goes from one term to the next by always adding the same value. So in this example over here, or these two examples over here, 2, 5, 8, 11, and 14, to get from one term to the next in the first example, we're adding 3 each time. So it's plus 3, plus 3, plus 3. It has a constant rate of change. In the second example, 7, 3, negative 1, negative 5, to get from one term to the next, we're subtracting 4. So again, this one is decreasing by the same value, the same constant rate each time. So that difference, what we add or subtract to get from one term to the next, is what we call a common difference. And that common difference, again, is what we add to get or subtract to get from one term to the next in an arithmetic sequence. So we use the letter D for that common difference. So again, it's the number added at each stage of an arithmetic sequence, because if you find the common difference by subtracting successive terms, you'll always get this common value. So let's take a look about what that means. So in this sequence right here, 3, 11, 19, 27, 35, you can probably look at it and say, well, I know that if I do 3 plus 11, or 3 plus 8, I'm going to get 11. 11 plus 8, I'll get 19. 19 plus 8 is 27. 27 plus 8 is 35, and so forth and so on. But if it's not that obvious, all you have to do is subtract one term from the previous term, or the previous term from the next term. So 11 minus 3 will give you 8. 19 minus 11 will give you 8. 27 minus 19 will give you 8, so forth and so on. So when you see this common difference right here, that tells you that this is an arithmetic sequence. So the common difference in this case is 8. And if you remember, when we did a now next, our start in this particular sequence was 3, and our next was equal to now plus 8. And that plus 8 was the same as our common difference. So we're just going to fill that in over here. The common difference for this particular sequence is 8, and the next term in the sequence is just 35 plus 8. And to get the next, we would do, and that would give us 43, and we can keep on adding plus 8 plus 8. And A1, which is equal to 3, is the first term in the sequence, and again, we use A1 for that. So let's go over and look at our formula from a couple units ago. So our formula for an arithmetic sequence, any term in the sequence, a to the n, if I want to find the 10th term, that would be a to the 10, is equal to the first term plus n minus 1, the quantity n minus 1 times the common difference. A1 is the first term, D is the common difference, and n is the number of the term that we're looking for. So we can use this now next, this arithmetic sequence, because it is increasing at a constant rate. This arithmetic sequence is also linear. So we can write a linear equation from an arithmetic sequence. The common difference is the same as the slope, and I'm going to erase that right there. So let's look at our now next from up here. So if we write our now next, or even our arithmetic sequence, let's say we're looking for a sub n. The first term is 3 plus n minus 1 times the common difference, and the common difference in this one is 8. So if we distribute everything, we get a sub n equals 3 plus 8n minus 8, and a sub n equals 8n minus 5, because if we combine 3 and negative 8, we get a minus 5. So this looks very similar to a slope-intercept equation. So if we replace a sub n with y, there's our slope, that's our common difference. The n is the same as our x, and in this case, our y-intercept is negative 5. And if you remember from when we did arithmetic sequences, if we take our common difference and we subtract our start, we subtract our common difference from our start, 3 minus 8 is going to give us negative 5. So what happens if we have a sequence that does not have a common difference? And we're going to take a look at the brown tree sequence right here. In this sequence for the brown tree steak, the rate of change is not arithmetic as shown below. So if we subtract one term from the next, we get a difference of 4. If we can continue to do that, we get 25 minus 5 is 20, 125 minus 25 is 100, 625 minus 120 is 500. So this is not a constant rate of change. So we get, for these 4 right here, it's not constant. So therefore, it's not arithmetic. So if it's not arithmetic, what do we call it? Well, if it's not arithmetic, we call it geometric. So let's take a look at the next. So the difference in the brown tree snake sequence is not a common number. Therefore, as I said, the arithmetic is not, or the sequence is not arithmetic. So what happens if we look at that data, and I'm going to rewrite it over here. When we look at that data, we went from 5 to 25 to 125 to 625. And how did we get from one term to the next? And we got from one term to the next by multiplying. So what can we multiply 5 times 5 to get 125? And the same thing times 25, or 5 to get 25, 25 to get 125, and then 125 to get 625. And what we did is we multiplied each term by 5 to get to the next term. So our start in that particular sequence was 5, and if we do our now next, our next was the previous term times 5. This is not going to give us a linear equation because we're not, it's not increasing by the same amount each time. It's increasing by different amounts. So if we look at a formula for a geometric sequence, and that's what this is, it's called geometric. Sorry, I forgot to write that in there. And a geometric sequence goes from one term to the next by always multiplying by the same number. And again, in the case of the brown tree snake, we're multiplying by 5. So in here again is a general formula for a sequence, for the geometric sequence, and that's a sub n, that's the term we're looking for, equals the first term in the sequence, and in our case our first term is 5, times, we call this the common ratio. The difference in a geometric sequence to get from one term to the next is called a common ratio. And so the general term is the first term in the sequence times the common ratio times the number we're looking for minus 1, similar to what we did in the arithmetic sequence. So, and again, in this example, in 1, 2, 4, 8, 16, we're multiplying by 2. And in 81, 27, 9, 33, 1, 1/3, we are multiplying by 1/3 to get from one term to the next. So since we're multiplying by 2 in this one, multiplying by 1/3 in this one. This is a geometric sequence. And we call that number, what we're multiplying, again, like the 5, or in this case the 2, in this case the 1/3, we call that the common ratio, and we use the letter R for the common ratio. And you can always find it by dividing successive terms. So if we were to divide 16 divided by 8, we would get 2. 8 divided by 4 is 2. 4 divided by 2 is 2, and 2 divided by 1 is 2. And back to the brown tree snake example, if we want to find the common ratio for the brown tree snake, it doesn't matter which pair you pick as long as they're right next to each other, as long as they're consecutive. So if we do 5 divided by 1, we get 5. 25 divided by 5, we get 5. 125 divided by 25, we get 5. And 625 divided by 125, we also get 5. So our common ratio, our R in this case, equals 5. And so the next term in the sequence would be 625 times 5, and that next term will be 3,125. So let's find the common ratio of these two examples down here. So first we'll find our initial term, and that's the term we're starting with, and in the case of this sequence it's 1/2. So how do we get from one term to the next? Well, I'm going to start with these numbers because they're whole numbers and I don't want to deal with fractions. So if I do 8 divided by 4, that's going to give me 2. If I do 4 divided by its previous term, 4 divided by 2 is going to give me 2. 2 divided by 1 is going to give me 2. And 1 divided by 1/2 is also going to give me 2. So that's our common ratio. Our common ratio is 2. So to get to one term to the next, to get from 1/2 to 1, we multiply by 2. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. So the next term in our sequence would be 16, then 32, then 64, and so on. So go ahead and try example 2. Write down the initial term, and then what is the common ratio. And then you might want to pause the video at this point to see if you got it right. Okay, so our initial term, the first term in the sequence is 2/9. To get our common ratio, I want to do 18 divided by 6. That's going to give me 3. Looks like our common ratio is 3. 6 divided by 2 is 3. 2 divided by 2/3 is 3. So clearly our common ratio is 3. And again, let's go back and write a now next for each of these. So if I wanted to write a now next, our start is 1/2, and our next equals now times 2. For example 2, the start is 2/9, and our next equals now times 3. So keep in mind, arithmetic, you add to get to one term to the next. Geometric, you multiply to get from one term to the next. Okay, now it's your turn to answer your 2 video questions. In number 1, look at the arithmetic sequence below. What is the common difference? So I'm telling you that it's arithmetic, and you are looking for the common difference. What is D equal to? And in the following sequence, is it geometric or arithmetic? And in your answer choice, just write geometric or write the word arithmetic. That's all you need to write. So how are we getting from one term to the next? Are we adding to get from 1 to 3, from 3 to 9, from 9 to 27, 27 to 81, or are we multiplying by something to get from one term to the next? Be sure to enter your answers on the Google form.